start recording it now. Everything you do will be recorded. If you choose to speak or open your camera, feel free, if you disagree with that, to come in touch, reach out somehow, talk to me, and we'll see what we can do. We can blur you out, we'll see what we can do. Now, next slide. I don't even, yeah, finally, it's there. The battle that we were waiting for, TypeScript versus JavaScript. Radu has a very solid experience around this fight. So yeah, he will be the referee for today. Radu, I will turn the spotlight to you, and then the event is yours.
Thank you. Let me share my screen. I prepared an online presentation for this subject, and let me copy the link so that you can all access it now, later, up to you. Where is it? Where's the chat? Where's the chat? All good. Everybody seeing it right? Can you see the full screen version now?
Yeah.
Sure.
So diving right into the subject, I was first acquainted with the whole TypeScript technology quite a few years ago, and we have used TypeScript in quite a number of projects over the years, from the point where the technology was beta basically all the way to the current moment. But we did not apply it as a standard within our company. It was something that we were having in certain projects, in certain areas. Some developers were particularly happy with the technology and interested, and were applying it wherever they could, whilst others were posing quite a bit of resistance to the idea of using TypeScript. And this year was one of the moments where we decided that we need to take all of this knowledge and all of these experiments that we have done over the years to come with a conclusive decision on whether we want to expand TypeScript to apply to all of our code in JavaScript, or if we now eliminate the technology, or if we somehow decide that there's a particular circumstance or type of project for which TypeScript applies and for which it doesn't. And taking the step was particularly important in order to come to a conclusion with regards to how TypeScript is used, because over the years, we have used TypeScript in quite a number of ways. Certain projects were requiring you to define types for everything that you were using, and some other projects were much more relaxed about your implementation of TypeScript. And then came the question about what is the right way to use TypeScript in order to get the benefits. And then came the question, what are the benefits? And so we went a couple of months ago through a series of internal debates within our technical team here, attacking the subject from different angles, people exploring possibilities independently in order to try to bring to some degree objective analysis about the benefits and disadvantages of TypeScript. The biggest hurdle to overcome was this circumstance that's quite frequent in software development, where you have sides, you have these little camps forming who almost religiously defended their perception and the decision, and we had that here. This was one of the most divisive subjects in recent years, where about almost equal half of the technical team, some were strongly in favor and some were strongly against, and the two sides would present only the arguments that were pushing forward the conversation towards their side. And this created a quite difficult debate to navigate, which we did somehow successfully manage, which I wasn't expecting, to be honest. But at the end of this series of discussions and investigations, we got to the point where the entire team was on the same page, and everybody had effectively voted in favor of applying TypeScript across the entire ecosystem. Which was a conclusion I was not actually expecting to reach, because some of the people in the beginning of this dialogue were very strongly against TypeScript. And so now I'm hoping to take all of these lessons and share them with all of you. And particularly valuable, I think, is the process that we went in towards analyzing the technology in a way that allowed people to escape from this state of mind of being strongly in favor or disfavor. So at the end of the discussion, those people who were in favor finally did admit that there were good arguments against the idea of using TypeScript and vice versa, only to be able to make a practical assessment to decide that for our team, for the state of our product and ecosystem, the decision is clear in favor. Although this might not be in general applicable. Depends on the team that you have, and also depends on the life cycle of the product that you're attempting to apply the technology for. So that's a detailed intro into what we will be looking at. Now, a little bit about myself. My name is Creoșteanu Radu. Don't try to pronounce that last name. It's a Romanian name, which is where I'm originally from. I moved to Germany almost 8 years ago. I started programming in '94 as a kid when I got a programming book from my parents. I've been doing JavaScript since 2007 and got into the whole TypeScript subject in 2014 when the version that was available at the time was 0.9. And since then been involved in different degrees with around 42 TypeScript projects, which, as you can imagine, many of those are quite small. So it's sometimes even libraries or very, very small code bases. And some of them are very large in the order of tens of thousands of lines of code. You can also find me on GitLab and Twitter if you're interested in any kind of communication with me after this presentation. I am the Chief Technical Officer at Fleetster, which is a web development company. We provide a mobility software called fleetster, which provides the functionality that you can see here. And now I just realized I put the German image, probably should have put the English one, but I think most of us understand enough of what's written in there to understand what the primary product offers. So now let's dive into the subject. What is JavaScript? I think most of you are familiar with the rise of JavaScript as one of the most popular languages, programming languages for web development in particular, although its user space has now expanded quite considerably. In Fleetster, we use JavaScript pretty much everywhere, server-side, web, and mobile, and in some cases even embedded through still Node.js. And our biggest drive for using JavaScript everywhere was to help the development process, to speed up development process, and to allow developers to become truly full stack. So one developer is able to build the feature across the entire ecosystem without being dependent on some few components or API endpoints that might or might not be developed in the future. But JavaScript has a very lengthy and troubled history, coming from an age where the implementation of JavaScript was not very uniform, and the language itself has had to provide very lengthy backwards compatibility, because in practice we still have access to var. And if you're using var, you're being naughty, don't do that. But this creates a circumstance where if your project has a high reliability demand, it's not just a small piece of script running in the browser somewhere, but you are providing a caching service that needs to be able to have 24/7 availability and implement the necessary protocols to lock and unlock physical vehicles, the reliability requirement becomes quite high. So how do you make what is inherently an unreliable programming language reliable? And this is where the concept of TypeScript comes in to save the day, where the idea of TypeScript was to expand the capabilities of the JavaScript language and add to the language functionality that is present in more traditional programming languages, or in the programming languages that underline most of what enterprise software is. So you won't find much JavaScript in banking. And this is one of the reasons why TypeScript has tried to learn from those techniques and import one of the key functionalities, which is static types. And here comes a little bit of a disclaimer. So I came into the whole JavaScript community from a heavily or a strongly typed background. So I had been working with C and with Java before for quite a number of years. And I fell in love with JavaScript, particularly because it didn't have types. So the whole dynamic typing, the flexibility of the language, and the ability to write code quickly was one of the things that attracted me the most to JavaScript, where TypeScript is sort of pushing me back to the old days where I was frustrated by having to write a lot of code to accomplish something very simple. And so there already points to sort of the internal conflict that I myself had with regards to this, where I was like in the middle of this fight, and I could see benefits and disadvantages to this subject. It could not really decide against or for this technology. And so the biggest challenge was to understand, how can I make a constructive dialogue around this subject, around something that is fundamentally very subjective, because it's about how we code. It doesn't really affect the end functionality. It's really just about the coding experience, right? This is its primary purpose. And that's made it very difficult to have a effective analysis. So we realized, okay, why do we care about TypeScript? So how can we center this dialogue around the main points that this technology affects? So we destructured our conversation. We realized, okay, what really matters, or what the impact of this technology will be, is development speed. How easy is it to write code, to get code into the master branch? Or GitHub is renaming it now. So what is it called now? Now it's not master, it's main or something. So, okay, we will use the old terminology, but development speed is one of the things that's affected by TypeScript in multiple different ways. It's one of the impacts that it has. But aside from that, the one that is particularly advertised for the technology, one of the main reasons for its application, is the impact of TypeScript on stability and reliability. And this is another subject that can be analyzed. And the last part is about the impact using TypeScript has on the other people that are going to work with your code. What is the impact in terms of readability and the ability to understand code of other people by applying TypeScript? Is it making code easier to read or harder to read? And you take all of that, try to understand what matters for your particular project in order to decide, should I use it or should I not? Which of course is also dependent on how your team or your colleagues evaluate each of these points for them. Because we did rounds of voting on each of those points and found that some people were able to deduce an advantage or a disadvantage in each of those points. So it's important to understand what really matters towards your project. So let's start. Development speed. We've managed to put together quite a number of points that would affect the experience of writing code with TypeScript. So let's bounce in between the two sides. In terms of advantage, by creating types and interfaces and designating them to the variables that you're using, you are implicitly creating a documentation of your data structures, of your functions, of the interfaces that are expected to be used. So this will help a lot in terms of your ability to, I mean, it effectively avoids you having to write artificial documentation, and also helps with your own experience of developing, because it helps you to see how other functions might be used or could be used. So, I mean, many of you in JavaScript now have seen the benefits of TypeScript, because most projects now have interface definitions that you can import in your project, which will provide quite a bit of assistance while you're trying to write. Now, one of the obvious disadvantages, which has been at times much worse than now, so the technology is a bit more mature now, but even recently, so I had one of my colleagues facing a breaking change in the TypeScript update that he needed to do on his project. So he was doing a dependency update. It wasn't even a major version change. It was a minor version change, but yet something in the TypeScript version made that project stop working. So minor dependency update resulted in him having to spend hours to understand what is wrong now. And this is a common experience now that I've seen over the years, where it's a bit better now, but it used to be that you would end up spending a significant amount of time every time you were attempting to update your TypeScript version for the project. Maybe some of you had better time off for this, but this has been a time sink that we've noticed. On the pro side, using TypeScript allows you to avoid many small and common mistakes as you're writing code. So you won't find those in the testing phase or in the review phase, or when you're trying to make your stuff work. It does make it much earlier that you will detect many, many common mistakes, as long as you don't fight TypeScript. Because one of the not so pleasant parts is that many of those errors that TypeScript will throw when you're trying to compile your code, or even if you're integrating TypeScript into your development environment, the debug messages are very cryptic. At least to me so far, most of the times I just know there's something wrong on that line, and I just have to figure out what exactly is. Most of the times the error is not sufficiently clear for me to understand what the problem is. So, but at least I know there's a problem. And oftentimes in the past, I tried to say, okay, no, TypeScript is just being funny. It's not a problem. I'll just set the type as any, bypass the validation. I'm sure it will be fine. Reaches production. Turns out, it was a string instead of a number. And so your plus does something completely different than what you thought it was going to do. So your entire code was shit. So lesson number one, don't fight TypeScript. Even if it gives you a cryptic message, try to understand what that means. You have to do a bit of digging on the internet, but most of the time TypeScript is right and you're doing something wrong. But that once you're on board with this principle, it helps a lot by notifying you of common mistakes much earlier in the process. Also provides implicit access to the latest JavaScript features. So you've got everything, imports, exports, and all the nice functionalities that you might need, all being compiled in a cross-platform, cross-browser compatibility, which makes development in many cases nicer. However, it does mean you have to take the necessary time to write interfaces and types, and to assign those types for all of the stuff that you're doing. Sometimes TypeScript can infer the type by looking at how you have used it so far, but not always. And it's sometimes not clear if you should rely on the inferred type or declare the type. So that's a little bit of a balancing act, but it will take time to write those interfaces. On the other hand, it is quite good to force yourself to think twice about your data structure and to really understand in depth how you're going to be using that data now and later. And so this forcing developers to think about the interface and the type, even though it will consume time and effort from you, tends to help a lot in ensuring that the entire thing comes together in something that will do what you want it to do, and that you are anticipating potential problems much earlier in the process. You can probably already notice a slight pattern here. Another part is it will take you a little bit of time when you're starting a new project to write the TypeScript configuration. Even though I have to admit, once you know TypeScript and once you've done it a few times, creating your configuration, most of the times you just copy whatever configuration you had in another project. But this also factors into the subject that you will need to learn TypeScript. You will need to spend the time to understand TypeScript, what it does, what it can do, and sometimes looking for answers for how do you declare a type for an array that contains booleans, or for a matrix that contains booleans, where once you know, you know it, and you probably won't need to search it again. But those are all pieces of the language's functionality that you will need to spend time in order to learn and understand and apply, which if you just wrote pure JavaScript, you wouldn't. So that's another disadvantage. In general, using TypeScript, because it detects problems earlier, seems to speed up the time it takes for a merge request or pull request, depending upon which system you use, to be reviewed and accepted. It reduces the amount of rejections, which implicitly means you're transferring time away from the reviewers to the developers, or the developer of that merge request, which is generally desired. And nobody wants to be rejected. So reducing the amount of rejections you get is generally a favorable point. And overall, for the team that's working with a particular project, this does seem to result in an overall speed benefit. And now comes another disadvantage, which is you have an extra build step in your project. which of course, if you have integrated your development environment nicely, then it's relatively seamless, but it is a second to free of every single execution. And I don't know about you guys, but as a developer, I tend to be obsessive about the execution time. I want my test to be instantaneous. I don't want it to need to compile code. I just want to execute my test or build my project. The extra step is a very tiny fraction, but since I build projects and run projects a lot during my time, that couple of seconds lost is still accumulating to some time that I want to quantify. To wrap up the whole development speed comes the subjective element of it that I have seen both sides of within our team. Some people like TypeScript, so as in they find writing code with TypeScript enjoyable, motivating, fun, which tends to increase the time it takes for them to develop, to decrease. It saves them time because they're motivated, focused. Whilst other people will dislike TypeScript. They will find it tedious and annoying. And so it will slow them down. And so this is one of those points which really depends on the person and the team. And I guess many of the following parts of this discussion are subjective. And that's one of the pieces of the story, I guess, that I took away from this, which is the answer to this question will still fit to the team that wants to use it. Where if you face significant resistance from people who are considering to adopt the technology, then you probably shouldn't, or try a sort of slow, gradual transition and adoption of the technology. Before moving on, anyone have any questions or ideas about points that may not have been considered within the scope of development speed? Anything you would like to add to this part of the presentation? Sure, I'm going to take that as a no. Am I muted?
Yep,
No,
I guess so. And guys, you know, you can very well type your question in the chat if you want, and I think Radu, you can answer it in the end, or do you prefer to have some interruptions here and there?
I mean, in principle, there would be a moment to sort of have questions and answers at the very end, but I just thought that perhaps someone might want to add a particular question or point to this part of the discussion. Now I clicked and I don't know how to go back. So yeah, I'm stuck. Okay. So I guess we are moving to the next point now. So next subject is service stability or reliability. How is the existence of TypeScript within your development process affecting your end product? Is it going to be less reliable, more reliable? And what is the practical assessment of this impact? Now, here's a key point, which is, as our team was 100% under this assumption or agreement, which possibly is also relevant for you. We have a very high coverage for automated tests. And in most projects we have, we aim for 100% automated test coverage for statements. And in some of those projects, we're also approaching 100% branch coverage. And so the existence of automated tests in our ecosystem does have a relevance to this dialogue, because TypeScript impact on reliability is going to be significantly higher in a project that has no coverage of automated tests compared to one where there's already a 100% coverage of automated tests. So if you have no tests, the value of TypeScript becomes more significant. But if you do have tests and you have excellent coverage with tests, and our team generally agrees that if there was a choice between these two things, where I don't think that automated test qualifies as technology, it's more like a development requirement. But if you had a choice between TypeScript and automated tests for your stability, because you don't have enough time to do both for some reason, then you go for automated tests. That's definitely much more important in terms of a development process than it is to have TypeScript, just as a disclaimer. So what is the impact of TypeScript in your ecosystem if you have automated tests? So, well, turns out there are some types of errors that are very unlikely to be caught by automated tests. Even if you have 100% branch coverage and statement coverage, data structure problems or issues with regards to data structure and types can often not be detected by automated tests, because most automated tests, even the mean ones, generally assume data. They feed data to your code. But if data comes in from other places, or how functions get called and how the whole thing combines together, can result in the circumstances where the structure of data that's being moved around your program has not followed the correct convention. You've accidentally mutated data or done things you shouldn't have done. So this is where TypeScript comes to the rescue and catches some of those issues. On the other hand, even though now it's not as much of a problem as it used to be, we literally experience circumstances where the compilation itself of TypeScript caused problems, where something was perfectly fine in terms of pure JavaScript, but its practical result after compilation did not work as intended. Now, these were bugs in TypeScript that I don't know of any nowadays, but we suffered the consequences of this situation earlier in the implementation of this technology. And on the other hand, the existence of TypeScript acts as an extra safeguard. This is beyond the idea of catching errors that automated tests don't. It's literally that you have two quality systems that, even if they check the same thing, tends to act as an extra safeguard. Somebody decided not to write an automated test for a certain case or for a certain circumstance. TypeScript then comes in and acts as an additional safeguard. So if you have a service or a project that has a very high requirement for stability and reliability, TypeScript implicitly helps to protect against accidental issues. So on the other hand, the code that's running in production is not your code. It's the compiled code. Okay, for browsers, if you're writing JavaScript for browsers, you're not writing JavaScript that's going to run in the browser anyways. You're always going to use some kind of compilation. You're using Webpack, you're using Babel, you're using something that's transpiling your code anyways. But if you're running Node, then you could just run pure JavaScript. And then the code that's running is the exact code you wrote. Now, as with the previous point, it's quite unlikely that you will have a problem in terms of stability from the transpilation or compilation of your code. But having your actual code running in production has some secret advantages, which you probably should never make use of unless you find yourself in the unfortunate situation where you have introduced a problem and you need to fix it live because, I don't know, your deployment process is taking an hour for whatever reason. It's slow. But the problem is now, and it's just about switching one character in your code. Doing that with compiled or transpiled code is quite painful. But if the code that's actually running in your Node.js on the server is exactly the code you wrote, just getting into the server, probably getting into the Docker image and changing that code and restarting the Docker image is probably going to be a bit faster. You might save 20 minutes, which in most cases, you probably shouldn't do anyways, because you're probably just making the problem worse. But having the option sometimes is good. Going back to the advantages, you've got static typing. And this generally tends to help ensure the reliability of a system. There's a reason why C and Java are the language for enterprise and not Python. It also acts as a little bit of a protection against regression. So if you discover the bug and you realize, my type was wrong, I need to adjust the type to avoid this problem in the future, or adding a type or an interface, it won't allow anybody else to reverse this or to accidentally bring back the same bug you fixed. And this also factors into my next point. It does help with refactoring and restructuring. Maybe you decide to change your function definition. You swap two parameters and then you forget to swap them in another part, but your automated tests are functional tests, Unix tests, testing those functions in isolation, not the combination of the two functions. And so if you have TypeScript, it's going to fail. It's going to tell you, wait, this function expects a new interface that you haven't adjusted when you're calling it. Change it in both places, please. And now we get to the subjective point, the one that was hotly debated in our team with no conclusion, which is some people feel the fact that Microsoft is underlying this technology is a good thing, and some people feel it's a bad thing. Microsoft doesn't have the greatest history when it comes to reliability of browsers in JavaScript, so it's not considered a good benchmark for that. On the other hand, they are a relatively well-established company in the general ecosystem of development and have some excellent tools and excellent other programming languages. So it does mean that the library is probably not going away, and it's quite likely that Microsoft will continue to make sure there's progress being made with the technology. So you don't have the fear that it's suddenly going to drop off. The one developer that was pushing this library disappears off the map and the library becomes deprecated. On the other hand, it's Microsoft. So pick your poison. Anyone want to bring in some additional questions or points to the subject of stability?
I don't think so. Although me being a Microsoft friendly developer, I don't quite understand the con of being backed up by Microsoft. But yeah, I get your point. I totally get your point. Then again,
people get very emotional around the subject of Microsoft, I think. So yeah. Okay. So to already draw some of the conclusions we will see at the end. When it comes to service stability, in general, you can deduce that this will almost certainly have a Somebody want to say something? Okay. So it's highly unlikely that TypeScript will reduce the stability of your service. Most issues are likely to be, if there are issues with compilation or something, are likely to be immediately visible. And the existence of TypeScript is likely to improve stability. The main challenge is to understand by how much. Because if you do have excellent coverage with automated tests and you're writing tests in the right way, the impact of TypeScript is likely going to be a lot less than what is officially advertised. There's on the TypeScript homepage some statistics there where I have to ask how exactly those statistics were calculated. But TypeScript claims it reduces bugs by, I think they said 15%, where I'm not sure where that number comes from, but I'm sure it's true. It's the internet. It never lies. As far as software development speed goes, it depends. In general, it seems like you, or at least in our case, we came to the conclusion that it's likely to speed things up, but not by a lot also. And depends on who you're talking about. So if it's a more junior member of the team, the existence of TypeScript is likely to help him more, opposed to a senior member of the team who is more familiar with the code, with the data structure already present, and has a particular methodology for verifying his own work that's likely reducing the relevance or the benefit of development speed by TypeScript, whilst he still has to spend the same amount of effort into building those types and interfaces and so on. So moving to the last area of analysis, code readability. I think this one's the most subjective out of the 3 points, and the one where there was no real data to rely on. So for the other 2 points, we could sort of say, from our experience, this is what we saw and so on. This is the one that's most subjective and requires, I guess, an open dialogue between the two sides in order to try to understand the relevance of this point. On one hand, the existence of types and interfaces, or types specifically, makes it much easier to understand what a function gets in and what a function gives out at a glance. So you go to the function, and if generally you have a code structure that's not with 50 statements within a single function. So if you have good function names and decent sized functions of 10, 25, 30 lines of code, then the function declaration with types makes it much easier to understand what you can use it for, which parameters are optional, which parameters are required, what do those parameters do. So this improves readability in general. On the other hand, you've got a lot of extra characters extra code, which are telling you things which are not necessarily relevant to the essence of the function. They're not related to what the function does specifically, but the code is in your visual spectrum. So there's literally more characters to read. It takes longer to understand and go through the entire function. Interfaces do make it much, much easier to understand the data structure and the data structures that your project uses, especially if you're dealing with complex data structures or objects. So if you're using JavaScript with something like Mongo or a document-based database, you will tend to have complex objects in there that fit well with the usage of JavaScript in various places, but those are complex data structures, not like in relational databases. And understanding the content easily of your data structure, you don't want to end up in the mongoose schema to try to deconstruct what exactly is going on with these objects and how are they intended to be used. Having the interface helps with that subject quite a bit. However, your code, the code that you write is larger. You're literally spitting out a lot more code. In some cases, we can see that TypeScript ends up to achieve on a particular functionality, writing 2 times as much lines of code, if that's a measure that's important. And in terms of code review, for the reviewer, this can have an impact, because instead of reading the functionality that the actual JavaScript code that was written, he's also reading the interfaces and all of those things where you should read them and you should verify them. On the other hand, it's not that hard to review an interface. And as discussed in the first point, the presence of the data structure in such a simple visual way generally tends to help people think through the data structure more. And the data structures is one of the things that tends to generate a significant amount of problems, bugs, and migration nightmares. So it's one of the subjects where it's important to apply focus and attention. So this is something that I generally find as a worthwhile disadvantage. If you're using a modern IDE and you've properly integrated TypeScript into your IDE, the inbuilt navigation actually allows you to easily travel to the interface or to the type and to whomever is using those interfaces and types, which makes traveling through your code easier and allows you to access the information you might need to understand the code easier. And then comes the last point that falls under both sides. Some people like the TypeScript syntax and find that it is making the code more readable, as opposed to some people which find it harder to read. This is another one where I think here it's also a bit about how much you've worked with TypeScript. So in our team, what I noticed is that the individuals that were more front-end oriented and have generally specialized more in front-end features tended to dislike TypeScript more and the syntax of TypeScript compared to the people who were more back-end oriented and working with microservices in particular, where the syntax was feeling more natural. And I think if your team gets on board with TypeScript and you have a general adoption of this across your ecosystem and you standardize how you use TypeScript, because that's another point. So if you just decide, yeah, we're going to use TypeScript, but everybody uses it however they feel like, the result makes a lot of the benefits less significant, but can also amplify the disadvantages, because then everybody has their own configuration for TypeScript and the way they declare types. Do you have a global DTS? Do you put the interfaces in the same file as your actual TypeScript code, or do you extract it into an interface DTS file? All these little code styling differences tend to amplify the difficulty of reading code in multiple projects. If everybody applies similar or the same standards, it makes the code readability subject easier to digest. And that was one of our conclusions, that in order to amplify the advantages and minimize the disadvantages, it was very important to come to an understanding and agreement about how TypeScript should be allowed or applied and what the best rule set is. So in our practice, we use ESLint. We have the TSLint plugin, and then we apply the a specific rule set for code structure that we believe is right. So now taking all these different areas of analysis and putting it together into some kind of conclusion. What are the main takeaways that we understood from this? So in general, it seems TypeScript benefits more new team members or junior team members or people who are newer to coding in general, which may feel counterintuitive because it doesn't mean those individuals have to spend the extra time to understand TypeScript and learn TypeScript. But junior team members, from our experience here, tend to suffer the most from creating code that has problems in production and then fighting to fix those problems, or in the review process. And TypeScript tends to help deal with those problems much earlier, and then also helps with the learning process. So that's one area where I feel that is important to highlight. TypeScript makes you feel smart by helping you avoid stupid mistakes. So it's more than once where I've discovered I've introduced a silly problem in the end result because I just didn't pay enough attention, or I just assumed something, or and TypeScript just helps to take all of those away so that I can feel better about myself. If you are writing code and TypeScript is telling you, you're doing it wrong, you don't feel bad. But if in the code review or in the QA phase, you get rejected for your merge request because you did a silly mistake, it just feels wrong. Regardless of how you use TypeScript, it's likely it will improve your system stability. How much depends on your project and how you use it, but it's almost certain that you will improve stability. So depending upon your project priorities, this might be important. In general, how I look at the problem is that if I were to introduce TypeScript or to take the decision in a new team, new project to use TypeScript, I would see this as an investment into the skills and knowledge of the technical people in that team, but also in the long-term health of the product. And that's a decision I guess people would have to make. Do you have enough energy and resources for the long run, or is your objective more short-term? And also in the same way relates to the life cycle of the products that you're working with. Are you dealing with a startup and you need a prototype, you need to prove or to showcase the functionality, then probably you don't care so much about stability and the long-term health or the even technical debt. You just need something quick to prove your point. Where probably TypeScript is not right unless you're dealing with people who have been using TypeScript, and therefore for them, the existence of TypeScript is helping them move faster. But then if you are going through the experience that most startups do, where they say, yeah, we don't care about the feature, let's just build a prototype, and then you have the prototype, and then they say, okay, now the prototype has to sell, so make it work. Which is an unfortunate reality in most circumstances. Then maybe you should sneak it in. Or if you're at the end life cycle of a product that doesn't have TypeScript, it's probably not the right moment to start putting it in. So if this service code base is moving into deprecation or maintenance mode, it's probably not worth it to bring it at that end phase of the project. But depends on what the requirements of the business team are. That's sort of what I've been able to derive from this. Just to get back to the 3 areas of analysis. In our case, after analyzing in depth all of those 3 subjects and having everybody vote in each of those points with a high majority, so 90% of the people voted in favor for each of those 3 individual points. But interestingly enough, the people who were against or who felt that TypeScript was not helping in those areas were always different. So the subjects seem to affect people in different ways. So conclusion, as far as I'm concerned, the clear winner in terms of most circumstances is use TypeScript. You'll have to take the time to learn it, and it's an investment, but it's an investment that pays off. I would even venture to say it's not about the long term, it's actually medium term, and then from there on. As long as you're not running or sprinting towards a short-term objective of delivering something in the next month, then probably it's worth it. where I would assume most of the people who are in this meetup feel the same. But I am now happy to hear your thoughts or questions. Anyone?
Very, very interesting, I would say. But I think a safe conclusion would be it depends who wins.
If I can say something, I've started studying front end. I then done like from the autumn to now, and I feel like JavaScript is more reliable. That's maybe just my inexperience with TypeScript. We started with TypeScript in our course, so I'm not really sure about TypeScript right now. So then this what I feel is JavaScript is more including for me as I feel like in front end. I'm not. I'm just saying this as for my experience, basically.
So thanks for sharing. Could you elaborate a little bit? So, if I understood correctly, you said that you feel from your experience so far in your university course that JavaScript is more reliable than TypeScript.
For now, right now, for me right now, because we have started working with TypeScript right now in our project, our end project for our JavaScript course and our front end, I guess. And for right now, I feel like JavaScript is more easier for me to understand than TypeScript, basically.
But now you're referring to the ability to understand code, or how stable it is in the running of your service or application. Because to me, when you say stability, I think, when I take my code and I put it in my, whatever it is, my device, my web server, my front end, it will have more or less bugs. Is that what you mean by stability, or are you thinking more about how easy it is to understand the code and how easy it is to write code?
Yeah, how to understand easy, because I feel like it's much harder to understand TypeScript in that way, because
which is a good point. So this is sort of what I was trying to highlight as well, especially since, from what I understand, you're in university. It takes an additional investment, right? There's a barrier of entry in a sense. So I think it makes, if you had a circumstance where you are learning JavaScript, then I don't think it makes sense to do TypeScript. TypeScript is something you would do after you have learned JavaScript. I wouldn't learn TypeScript first. So JavaScript, you should you should learn and know how to use JavaScript, and then you go into TypeScript, because you will need all the lessons you have learned from JavaScript in TypeScript, but TypeScript has a lot more functionalities, features, capabilities, which can make it confusing, can make it harder to understand. What's the purpose of all? I mean, as I was referencing at the beginning of this talk, when I started learning programming many years ago, I was quite frustrated, and also because of understanding. I thought, what is this public static void main? What's public? What's static? What's void? I don't want to know what all of these things are. I just want to write a function. I just want to print something to the console. Why do I need to write all of these class, public static class names, all of these different words, and what do they mean? And I don't have the necessary time to go into and understand all of these things about programming. I just want to write code. That's why generally when I'm dealing with people who are getting into programming, I say, none of that C, Java, or anything of that sort. Start with Python or JavaScript. Something that's nice and gives you easy development experience. You don't need to know everything JavaScript does, because you just start with variables and start executing code. And that's a very nice experience, I think. And it's very important in the idea of learning how to code, to have instant gratification, because that's what era we live in, right? The game needs to give you some good endorphins. You want success now, not after 6 years of learning. So I would agree entirely in the circumstance that you describe, where I'd say, no, in your situation, JavaScript and understanding everything about JavaScript first makes a lot more sense. Because I'm also assuming stability is probably, as in production stability of your front end is probably not a priority on any level.
Yeah, we have started making basic sites and like that. It's like we are working with TypeScript right now. Working with P5J as our library. We're making a game as for our end project for this course, And then we're gonna go more in depth later on with the stuff in our course.
Yeah. So in that circumstance, that game is probably gonna be like a showcase. They're gonna look at it and say you get your grade, but it's not like there will be 40,000 people playing the game.
No.
And you have a bug, and then everybody's calling you and saying, fix it.
Yeah.
Yeah. So yeah. So like George was saying, the answer always depends, and this is one important lesson in programming. In most cases of technologies, there's a right and a wrong. It's just about understanding which context do you find yourself in and what's the right tool for the job, which is a very frustrating answer because it's basically saying there's no right and wrong. The answer just depends. You figure it out. So anyone else who has ideas or thoughts that they would like to share?
Maybe I have some more practical question. So since TypeScript is super language on top of JavaScript, and actually JavaScript is in some way a valid TypeScript code. TypeScript allows in some cases to fake type system with, for example, any type, and that can bring some mess in the project if it's used in some wrong ways. So how do you deal with such situations? How do you avoid like skipping type system in TypeScript projects, especially when it goes about a combination between some old code, which is pure JavaScript, and TypeScript? Do you have some policies on that?
Yes, excellent point. Yes, this is as I was mentioning earlier in the presentation. This was one of the things we noticed or realized, which is that we were losing a lot of the advantages and amplifying the disadvantages of TypeScript by not having a standard way of using the language. So some people would have, as you describe, a project where they've effectively applied TypeScript, but not really using TypeScript. They're literally just using JavaScript. They just called the file .ts, which is not very good in a sense because you don't have the advantages of TypeScript. On the other hand, the ability of using TypeScript with just pure JavaScript is a significant advantage for the subject of migrating code, which is not one of the things I was focusing in this presentation a lot, to understand how can you easily and smoothly migrate from your non-TypeScript project to one that does use TypeScript. One of the, and that's a talk in itself probably, or I think it's one of the lists I sent you, George, of the things we could discuss. But we have this experience where we had these pure JavaScript projects with thousands and thousands of lines of code, and then we cannot rewrite this in TypeScript. We don't have a month to now spend on rebuilding this project, but we want TypeScript. So what do you do? Well, luckily there's like a migration strategy. And for the specific case that you were referring, what we did is, first there's ESLint, which you and probably everybody's aware of, which you use to apply rule sets to how you write code that are stylistic. They're not necessary per se, right? Your code can function without them, but it enforces a set of standards in how you can write code, right? Everybody knows the whole topic about semicolon or no semicolon, right? And it's a question that has been asked across programming languages. Python doesn't have the semicolon, right? It doesn't have any way of ending a sentence. It just says indentation matters. It decides what you're trying to do by how many spaces or tabs you have at the beginning of the line. So we use ESLint, and ESLint has a set of rules available for TypeScript specifically. And in there, we have normally specified a certain set of standards that require you to specify types and to disallow explicitly the any type. So that when you're writing code, you have to do it properly. There's no wiggle room. The job will fail. When you push to merge review, ESLint will run and will say, no, you cannot push to review because your code is not compliant with the standards. So what we did when we were trying to migrate projects is we added the ESLint rule, but we also added a line to all of the existing files to disable the rule for those so that we could gradually fix code over time. But any new code, any new file that would be added to the project would have to be compliant with that rule set. So this is what I advise teams to do. If you're starting a project from scratch, definitely just put ESLint from the beginning and say all the necessary requirements for healthy TypeScript usage. Where they are, if you are taking the TSLint plugin, which is the one that makes sense, there's also the recommended rule set, which will already give you a good starting position for what makes sense to use TypeScript with. So with a new project, you would do that. And if you're trying to migrate a project, you would still add those rules, but you would disable the problematic rules, the ones that would require weeks and months of effort to comply with for specific files, so that your project can gradually be migrated to a healthy state. Does that answer your question?
Yes, thank you.
Anyone else?
I think, yeah, is my microphone open? Yeah, it is.
Yes,
I closed it because, yeah, you know, one of the strong things in JavaScript, which I personally don't like at all, it's the ability to do things in multiple ways. There are so many ways to do things. There are so many ways to handle errors, potential errors. This loose type approach, it's very appealing to many people, and I can understand that, especially for small projects that you just want to start and do something, that is super, and it's very helpful because you can write something and that's it. But in the long run, and especially if you are getting into a bigger project that you always care about the next developer, then it's the funny thing, I don't remember now who said that anyway, that says you should always write code as the next developer is a maniac that knows where you live, a psycho that knows where you live. So in JavaScript allows you to not to do this, because you can do so fast and so easy many things. You usually disregard patterns and well-written code, and you just want to finish what you do. And this is totally fine in some cases, but I really like TypeScript just because it forces you in a way to do things in a specific way, and that makes it more readable for the next developer and actually more maintainable within a team. Of course, on the other hand, and let me share my screen, there is a nice page. Is this one? Yeah, and I can zoom it. I don't know who knows that. Some guy sent it to me time ago, some years ago, and it's actually talking about vanilla.js, how good it is, and how all these big names actually use it. Maybe it would be through Angular or through, I don't know, React, but they are actually using vanilla.js. And the funny thing is that they are have this weird, let's say, wizard here on how to select the features you want, as all these frameworks have. And you're saying, I want prototyping and animations and blah, 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 and all these things. And it always remains the same. 0 bytes uncompressed and 25 bytes zip, because you don't need to do anything. You just have that there and you're using it and you're done. So there is always pros and cons in anything. And I totally, I don't know. I'm always puzzled by that. Of course, you, Radu, are massively more experienced in that. To be honest, if I had to make this kind of choice in my company, I would refer to some guy like you that has all this massive experience to help me out. But my initial thoughts would be, if you want JavaScript, to do some silly JavaScript thing on your own, some small page, some project that you will mostly work on your own, then do it in JavaScript. If you want to build your own framework, your own TypeScript or Angular, then of course you will need to know JavaScript. If you want to learn Angular or TypeScript or whatever, then of course you will need to learn the basics in JavaScript. You need to have some foundations there. But if you want to go big and you want to work in a very big project that many developers work and come and go, then you most probably need the framework. And of course, there are other frameworks out there, but personally, I would use TypeScript just because I have this C# background, let's say, and it makes it easier for me to get into this world. Anyway, I know that it is far more complicated than this, but this is at least how I see it.
And I think you've hit on a key point that I was also trying to highlight in the presentation, which is the relevance of the languages or of TypeScript, of the technology, is particularly important in collaborative settings. So if it's you and your own code and your own project, and you are like the 90% contributor of it, you probably know every piece of code. Although some of you certainly have had the experience where you look at your own code that you wrote a year ago and you think, who wrote this code? But the impact of the technology is more relevant when you're dealing with multiple developers. So if you're working within a project where there's 10 different developers working in there consistently, all of them, TypeScript helps to ensure that collaboration is smooth. You are communicating through those types and interfaces with the other people. But let me give you an interesting, or for all of you, one last interesting experience that I myself had for myself. So about 5 years ago, I stumbled on a game on Steam called Creeps, which is scripting creeps. That's the idea of the game. And it's a JavaScript coding game where you write code that runs a mini artificial intelligence in a persistent world that fights other players. So the premise of the game was attractive to me. I like competitive games and strategy games in particular, and I also like coding. So it was like putting everything into one happy bundle. So I said, yeah, let's do this. And I thought, okay, well, this is an interesting place to experiment with writing code, not like I normally do. So I thought, what if I take all the normal rules that I have and I just write vanilla JS like George is showing us now, where I thought, what if I don't follow any of my normal code styling convention and start from scratch? How does it feel? And I basically went through a personal experiment for a period of like 3 years, writing code in scripts, where I started with just pure JavaScript. It was really fun. So I like started coding and I just started creating files and organic structures. And it was really enjoyable, especially for the first 3 months or so. But as the functionality of my pure JavaScript code grew, and it was doing more and more, and the game has unfortunately a lot of depth, which means there's a lot of stuff you can do in there. And so I started having more and more problems in production. I was spending more and more time debugging my own code, and I also had no automated tests at all. So I was starting to get afraid to click the deploy button. So I was getting to the point where I would enjoy writing code, and I would write a new feature into my AI for a week, and then it was coming the moment of deployment, and then I would like to say, you know what, screw this game. And I had to be sucked back in after a week, and then I was like, okay, let's test it. And then I say, okay, well, I have no testing environment. So it became increasingly frustrating as the complexity of the project grew, where after I took a break and came back 1 year later, I said, okay, this time we'll do it differently. This time I write pure JavaScript, but with 100% automated test coverage. And I basically had to spend the first week just creating a viable testing environment or a framework that could run automated tests for the game. And I effectively spent the first month without running anything in production. So I literally just built. And I was already feeling pretty bad because I thought, okay, this is never going to work. But then the day came and I deployed and it just worked. And I was like, what? But I spent then another good couple of months playing around with this approach and realized, okay, now this automated testing framework is making it much easier for me to eliminate the unpleasant experience of having to debug and test my own code. So that was definitely a step forward. But in this environment of scripts, it was also a circumstance where I was working with other people, and I was sharing code with them and working together with them. And one of the people I kept fighting with wrote AI with TypeScript and automated tests. And we shared each other's code, and I realized, okay, you know, his code looks pretty nice. His structure is pretty clean. I can understand what he wanted to do. And of course, it wasn't the same the other way around. So he read it and he said, it's very interesting code, but most of your code is cryptic. So I have no idea what you wanted to do here. I'm sure it makes sense to you, but I give up. So this personal experience sort of took me through each one of these stages of understanding the impact in a complex problem, right? If I had stopped after the first week, it didn't make sense to do anything else because the original experience of just writing pure JavaScript was easy to start with and very enjoyable and rewarding. but it just didn't work when the requirements changed, when it became a more demanding environment, so to speak. And here, I'll put in the name of the game if anybody's interested to check it out. I've spent an incredible amount of time writing code here, tens of thousands of lines of code, to the point where I'm ashamed. I think I could have made the world a better place if I didn't do that. But instead, I played games. At least I can say I was coding and learning something.
Scripts, let me share that. Let me put it here. Yep, slowly here. A more sandbox game for developers, programmers. Cool.
So
that's very cool.
I think we've approached the end of our presentation here. Unless anyone has some last minute question, one more question or statement that they would like to make, I think we can wrap this up.
I actually do.
Who?
Yaroslav.
Right, go for it.
And it's again a little bit practical. So I put in the chat a link on Stack Overflow question regarding types versus interfaces. And there is a table which shows that often both can be used a little bit, scroll a little bit down to see the table. More.
Here? More?
More.
And let me know.
And more. That's it. This one. So as you can see, in some cases you can use both, and it was not always clear for me in which cases one should use interfaces and in which cases one should use types. Do you have any comments on that?
Yes. I had a similar fight with TypeScript on this subject, where I was trying to declare a data structure, the one I mentioned earlier, where I was trying to create a matrix of booleans, and I was thinking, how do you declare this interface? And I created a very ugly interface structure, which in the end was doing what I wanted it to do, but it was really ugly. And then I realized, oh wait, no, this is wrong. This is a type. And then the same ugly interface turned out to be a one-liner type, where it was just type array boolean. So it can be a bit difficult at times to figure out which one of these you need. However, if you are using something like a modern IDE like WebStorm, you can cheat a little. In many of the circumstances, like I was mentioning before, types can be inferred from how you use them. So one of the things I often do is I write my code. I don't yet write the types. And then I ask WebStorm to extract the variable. There's an action for it, and or to extract a type, and it will give me if it's an interface or a type. So that's a little bit of a cheat. I know it works with WebStorm, which is the IDE that I personally use, but it probably works with most modern IDEs. And unfortunately, there is no easy answer. Generally, types are for primitive data sets. Things that, as in my example, right? I had a matrix of booleans, so it's close to a primitive. And interfaces are for declaring complex objects or classes. That's how I would look at it. So if you have, like in this example, in this discussion, an X, Y, it's probably you're talking about coordinate pairs, in which case I would feel that a type is more appropriate than an interface, where I would use an interface to describe something like a bicycle or a map or something like that, a complex abstract concept. This is what I would suggest.
I see. Thank you.
Cool.
All right, George, we're approaching your cutoff time, and I think we've covered pretty much everything. So let me take this opportunity to say thank you to all the people who dropped in at the end of today out of their busy lives to listen to me yabber on about my personal experience with all of this. I hope you will have found all of this information useful. And George will post this talk online anyways later, and I'll probably derive a blog post from it. and
Yep.
you're welcome to read it and share it.
Thank you.
Perfect.
Thank you very much for a very good lesson.
Bye-bye. Have a nice rest of the day.
Bye.
Thank you very much,
And Merry
Raju.
Christmas.
Everyone, whoever celebrates Christmas, Merry Christmas. Whoever celebrates New Year, yeah, just be careful. You don't know what's coming. 2020 was a weird year already.
Yeah, that's true. Yeah, looking forward to putting this year behind, but let's see what the next one
Yeah.
brings. Bye-bye.
Bye bye. Thank you.
Thank you, everybody. Ciao. Bye.
Bye. Thank you.